Good day everyone. This video will show you the tutorial about the T flip-flops. And in this topic, we will discuss about the characteristics of the T flip-flop, its logic circuit, its logic symbol, the excitation table, and also we will first discuss the theory of operation, then also we will simulate the actual logic circuits used for creating a T flip-flop using EWB and demonstrate the operation of the T flip-flops. Again, this is Dean Evander C. Dagum from BSECE 3C. First, we have the circuit diagram of our T flip-flop. T flip-flop is known as the toggle flip-flop because of its toggling operation. It is a modified form of the GK flip-flop. A T flip-flop is constructed by connecting a G and K inputs, creating a single input called T. Hence, why a T flip-flop is also known as the single input GK flip-flop. The defining characteristic of T flip-flop is that it can change its output state. You can change the output signal from one state, on or off, to another state, off or on. The clock signal must set high to toggle the output. When the clock is set low, the output remains as it is whether the input signal is set high or low. So, to change the output condition, the clock signal has to be high. Next is the logic symbol of our T flip-flop. Since T flip-flop has no circuit device in the actual simulation, we derive the logic symbol of our T flip-flop from the logic circuit of our GK flip-flop, where G and K inputs are set to 1 in order to form a single input values. Then we have also here in this side, which is the Q, where is the output of this T flip-flop, and our Q bar, which is the inverse of our output values. Next is the truth table of our T flip-flop. This truth table is also derived from our GK flip-flop, where there is if the input is set to 0, or if we toggle the input is set to 0 and the present state is also 0, then the next state will be also 0. If we toggle the input is set to 0, then the present state will be also become 1, and the next state will become 1. The next state of the flip-flop is opposite to the current state when the toggle input is set to 1. If we toggle the input is set to 1, the present state here is 0. The next state will be 1. If we toggle the input is set to 1, then the present state is 1, and the next state will be 0. Next is the excitation table of our T flip-flop, where it is derived and the same from our truth table. As you can see here, if we have the input here of 0, the values of T here and the values of our next state is the same. Then, if we have the values of our present state, which is set to 1, then the values of our input is opposite to the values of our next state. And let's go to the actual simulation of our T flip-flop. Here, as you can see here, this is the circuit of our T flip-flop derived from the circuit of our GK flip-flop, where this input is set to 1 to form a single input, which is our T. And we have also the input here, P, which is the presets, the T here in the our NAND gate, the clock that is correspond to the pulses of our waveform, then our clear or the reset here in our logic circuit. Then our clock here is set to low in order to see the waveform of our output in the oscilloscope. First, in this condition, when P is 1, let's start our simulation. When P is 1, here as you can see, when P is 1, our values, the circuit is in the set condition, which means the condition of Q will be the same as dt. If T is equals to 1, then the Q output is equals also 1, and vice versa. Then the next state here, or the next condition, is if we have the P is 0, then our C is 1. Our C is 1. This condition where the circuit is in the reset condition. The Q mains remains high irrespective of the value of T. Toggle input have the influence on the Q bar. The output Q bar follows the same condition as the T. The next condition is when P is 0 and our C is 0, the value of the toggle input does not have any effect on the input. They remain open always. Here, the next condition here is if we have the input 1 here, or our P is 1 and our C is 0, the circuit is in the set condition. It means the condition of Q will be the same as the T. If T is equals to 1, then Q is equals to 1, and vice versa. The last condition here is when our P is 1 and our C is 1, the condition here is in invalid. The value of the toggle input does not have any effect on the output. The output here is of Q is high for a while, then low, and Q bar is high. So it means it is in invalid state. And that's how the T flip-flops circuit simulation works. And I thank you.